Hi, thanks for checking out our channel. Here's going to be hopefully a repair video on a Dare Enforcer DE6400. This is a 16 joule output unit, so pretty stout unit joule wise. I mean, there's bigger ones of course out there, but this is a upper mid-size unit, I would call it. They make smaller ones. There's definitely bigger ones out there by different brands. But here's our information. If you'd like to send one to us for repair, we'll be happy to take a look at it for you. We give free quotes, and I'll tell you a little story about this model, why they seem like they had trouble with them. It's because of user error. And I don't know if this unit's got the problem, but if it does, I'll tell you why it happens and what to do about it, hopefully in the future. But excuse my voice if it's a little hoarse. I'm dealing with some allergy thing, I guess, and my voice is a little hoarse. And it's also hot in the shop, a little steamy. We got a couple big fans that are running, but the window unit we've had in here, we've been here 9 years, and it was here when we bought the place, and so it must be 10 plus years old, and the motor burned up on the thing and doesn't work. So we got a new window unit. We got one the other day from Walmart, and just haven't installed it yet. So I got the fans off, so now I'm starting to sweat, so I got to hurry up and get this thing finished so I can turn the fans back on. If I turn them on right now, you won't be hearing anything because the fans are about 8 feet from me and they're two big ones, and it'll be too loud, you won't hear anything. I got a little fan over here blowing on me, so not terrible. Some shit rolling around the inside. I found the note on there, see if it has what's the price in the repairs, all they're asking for. Alright, I see some discoloration on this transformer here, which some people will think they'll see like this bubbling up right here. That's pretty normal most times. That's just when it's pulling all the vacuum sealing this resin and pulling all the air bubbles out. Sometimes the bubbles will pop up here, and that's just cosmetic. What you want to do first is pull the transformer out, make sure it's no cracks in it. And this one doesn't have cracks. Yeah, it's got cracks in it. It's starting to swell up. See how it's raised up here on these edges here, especially along the side here. See these raised up area right there. The reason why this happens, it's not a fault of the unit. It's not really a fault of the customer, but here's why this unit goes bad. They got this toggle switch on the bottom here for half power and full power. People are like, oh, I want full power. I want as much power I can get. I want 16 joules all the time on my fence. I need all that power. Well, what happens is, check a few more things out, but what happens is if you have this unit on, I'm just gonna, and I know it says 2,000 acres, blah blah blah. That's a single strand, clean fence, perfect pie in the sky rating. If you got, and that's with 12.5 gauge wire. Now, if you got a smaller fence there, a smaller wire, multiple strands, cross fencing, braided wire, all that mileage and acres numbers go right out the window. But I would say on full power at 16 joules, you could probably easily run 500, 600, 800 volts, or I'd say between 500 and 700 acres of multi-line fence pretty easily with the 16 joule unit on full power. Now if you have it on a lot smaller area and you leave it on the full power, the way that this unit's designed is it's going to try to put out, say you put on like 75 acres, well it's designed to put out 600 acres worth of power on full power. If you only got 75 acres, even with some grass here and there and all multiple strands, this unit's going to try to put out all that power on a small area. Well, what happens is if it can't get rid of all of its energy because you do not have enough fence out there to absorb all the energy, all that leftover energy gets dissipated as heat. And the transformer and on the discharge side of the board, which is right up here all these wires plug in at, and you can tell right here it's getting hot. Transformer may not be bad, but we're probably going to have to change it. And unfortunately, don't have any transformers in stock, so we will change it once we get the unit to actually click and fire. We'll check the transformer primary first. If it's good, we'll leave the transformer alone for now. We'll work our way backwards. But you can see it's getting hot. It's swelling up. So they must have this on a smaller area from what it's designed to do, and it probably had on full power on the switch. So it's trying to dump out all that power, and it can't because the person doesn't have enough fence load out there to absorb it. So if you got one of these, put the thing on half power. It's still 8 joules. It's still plenty of energy for most mid-sized, acreage areas. You could probably run with an 8 joule output unit on a multi-line fence. You could probably still run 200-300 acres easily. So it won't run as hard. It won't run as hot. You probably prolong the life of this thing. How old is this thing? 2018, so it's 5 years old, 6 years old. So I don't know if it's ever been worked on or not. Sometimes they'll sell these things on Dare's website at like half price. That capacitor right there swelled up too, so people are stressing the things out, unfortunately, cause it to work harder than it needs to work, because they're not, the unit's not able to get rid of all the energy it's trying to get rid of, because you don't have enough fence load out there to let the thing release its energy out of itself. So all that extra energy it can't get rid of is being dissipated as heat and getting things hot. Run on half power, you won't have to worry about it as much. So we're going to have to order a capacitor. I don't have one of these. It's a 470 microfarad 25 volt. I do not have any of those. We'll wait on changing it, but we'll work our way backwards first. We'll work our way from transformer backwards. Output board looks okay. There's a burnt resistor down there, but it'll work with it. It'll work just fine. It's just a lightning protection board. Won't keep it from running. So first thing I always do, check the primary, the transformer. That's these two wires. I'll put our meter on ohms. We're just going to go across there, and we're on ohms on the lowest setting. Or fluke meters are auto range. So we're just going to go across there. Yeah, it's bad. Should be between 0.1 and 1 ohm. A resistance does not have a polarity. You can see I went black to red, red to black. If you go red to red, black to black, it'll read the same number most likely. See? So resistance does not matter on ohms. Resistance does not have a polarity. So transformer is bad. It should be between 0.1 and 0.9 ohms on average. If it's over that amount, this winding is starting to burn up on the primary side because it's gotten hot. And that's what this board up here discharges into the transformer, and the primary is basically a closed loop to allow the board capacitor to discharge into it. And if that closed loop, which is like 0.1 to 0.9 ohms, if it's higher than that, well, it's starting to open itself up a little bit more resistance wise, and that board and capacitor cannot discharge into an open, so things really start getting hot then because it can't discharge into the energy. So next thing I do, because we can sometimes fix these boards if they're not too far gone, is we'll check this diode here at the top. This is a discharge protection one, and it is good. The thing that goes bad sometimes is this SCR up here, and we'll pull this heatsink off the thing. Put it down there. We're gonna, the middle leg of the SCR and this back metal plate are the same contact on it, so we're going to put our meter, or red, it doesn't matter, well, I don't know which way it is, but put the red lead up top first, and we're going to touch the outside leg first. We're getting nothing. Let's reverse our wires and see if that makes a difference, because we're on the diode setting. Oh, that SCR is burned open internally, so it didn't matter which way we did it. It reads bad. Let's just check, make sure it's reading. See, we did the center pin to the back plate, it's the same. So we had a bad SCR, probably a bad capacitor there. The discharge protection diode is still good, and the primary, the transformer, is bad. Now I've got SCRs that we use on these things, not the exact one, but the one I like to use. It's kind of a universal one. It fits a lot of different applications for these, not all of them, but fits a lot of applications. It's also a higher amperage and voltage one, so it handles the power a little bit better on the discharge side, so hopefully it lasts longer. I don't have any transformers, so I'm going to have to order some of those in. But so that's what it needs. It needs a new transformer, put a new capacitor on there, and we'll fix that. We'll replace that SCR. I bet this thing will go back to working. Let's go ahead and check this capacitor real quick. It's probably fine. These blue ones on these Power Wizard or Dairy units don't go bad all that often. This particular one's an 80 microfarad capacitor, so it's going to cross it, no polarity. We're getting 82, so it's a little off, but not terrible. So capacitor's fine. Output board's probably fine. But we got to fix the board, hopefully, and put a new transformer in. So what I'm going to do, I'll probably make a part 2 video of this, or maybe I'll just, I don't do a lot of editing, but I got a little edit software on my phone. I can take 2 videos, blend them together seamlessly. You'll never know there was 2 videos. So we'll see. I'll see if I either make a second video, make a part 2, or here in about 10 seconds you might see it blend over seamlessly, and we'll just continue on once we get all the parts here. So we'll see what happens. So let's just go ahead and end it right now. Act like we're gonna stop this video, but there's our information, and we'll see what happens, and then we'll go from there. Till next time, see you later. And if you're watching this video and it continues on, welcome back. Here we go. Alright, this is a continuation of the repair that we started with on this unit. I was going to make a part 2, but I kind of blended the videos together to make it one long video versus 2 shorter ones. But anyway, this is on a repair on a Dare DE6400. So if I remember right, well, I had to wait on some parts to get here, but the capacitor swelled up here. I think the diode of this SCR was bad, so we got to replace this capacitor, which I have those finally. It's been about a week since we ordered everything. So I replaced the capacitor. I got to recheck this SCR and diode because I think one or both of those were bad. But we're going to do that. I think the transformer was also a little bit swelled up. So, but I'm not going to put another transformer. I don't have that here. Well, yeah, I think I do have one here. But we're going to check this diode real quick, see if it was any good or not. Yeah, it was good. Let's check this SCR real quick. Reverse my leads. This. Okay, the SCR is bad, so we'll change out. So at the moment, diode's good, capacitor and transformer were okay, I think, but we're going to change out this SCR as well as this capacitor, and I got to mark this capacitor. Oh shoot! Let me find a pin because this is an electrolytic capacitor, so it does have a polarity. And I'm going to mark the side of it here on this board with a marker. That's our negative. Get my soldering iron warmed back up. And then let's warm it back up. These boards are double-sided solder on top and bottom. So kind of pain in the neck to get things off there, but we're going to snip off that, and I solder to the top side. We'll get solder irons warmed up and find the SCR. This is the one we're going to use. This is a different SCR than what's on there, but it works great. It's actually got a little bit higher voltage and amperage capacity. So hopefully this capacitor will come off with not too much trouble. Pull the solder off the back side of the board. That'll be the easiest part to start with, and hopefully if it comes off and comes off the first try, then we'll install a new capacitor and go from there. I did get the quote to the customer. I said if this doesn't fix it, we're going to have to install a new board to the thing. Because there's no schematics for this stuff, so we do the best we can at testing stuff on the board. And then we just have to proceed from there. Alright, that came right out. So let's get the new capacitor. We'll get that soldered in. Make sure this is the right one. Alright, 25470. Right, one's a little bit different shape or size physically, but it's the same rating and everything, so I don't think that's going to matter as long as we get the polarity right. So it goes like that, and then we'll bend the leads over a little bit so that way it holds itself in place, and then we'll and as you can probably see or hear, my voice is a bit better now. I've finally got over the stupid cold or allergy problem. My wife's still dealing with a little bit of something, but she's alright. The kids are okay. Alright, let's set that right there. So what I got to do first on this SCR is I got to add some solder to each one of the tips of the legs on there. Ow. And then I'm going to add a little bit of extra solder on top, just give myself a little bit bigger surface area to work with. Alright, and then hopefully, if everything goes smooth, we should be able to widen this out just a little bit. Should be able to hold them right next to each spot and just heat them both up together, and just basically blend them together. 2 down, 1 to go. I'm not going to worry about the heat sink at the moment. We'll have to widen it up and stick it on there. But let's get the transformer wires plugged on. Capacitor wires plugged on. Alright, put this board back down this little spot there. Come on. Alright, let's get wires pressed on in there. Let's just plug it in and see what happens. We'll put another transformer in there if this works. sounds good. Let me go get my here, I'll go get my tester here in a second, but let's put a screwdriver across the terminals down here at the bottom. There's a little internal spark gap thing here. You just bridge it down there and create a closer gap, see if it sparks. Oh yeah. So it's working fine. So I'll get a new transfer for the guy. I got one in stock, or a couple of them in stock, I think. I gotta go and grab. So we'll put a new transformer in there just because it's good, but as you can see, it's pretty swelled up here. You see those little discoloration and swelled up spots around the edge there. That's been stressed out. So it might last another 5 years, 5 days, 5 months, 5 weeks, you know, something like that. So you never know. So I don't want to not put it in there and say, oh yeah, you're good to go, not charging, you know, not, you know, replacing it, and then the guy calls me back in about 2 weeks, say, hey, my unit quit working, and it being the transformer, maybe the transformer causes a problem in the board and won't let the unit run. So that's what we'll do. But anyways, thanks for checking out the last bit of this video, and we'll get this heat sink, we'll put that on. I gotta widen, it's a little bit thicker, I think, SCR it's on there, so I gotta widen the opening on that SCR or that heat sink, and then we'll slip that on there, and it would be good to go. It doesn't really need it, but you know, they had it on the first one. Let's put on the new one just so it helps things out. Maybe it'll last as long as it can. But anyways, till next time, we'll see you guys later on, and have a good rest of your day.